Okay, what is the delta H of formation of the hypothetical compound MgCl, given the information that we have here? Now, hypothetical, why does it say hypothetical? Not quite. It's supposed to be MgCl2, isn't it? That's the stable magnesium chloride. But if we had the right information, we could calculate the delta H of formation for one that doesn't exist. And probably the difference between the two is one is much more stable than the other. And, but that doesn't mean that the delta H of formation for this hypothetical one might not be negative, but we can at least find out. Okay? Now, I have, I think the best way to do this is to set up a cycle. And so we have magnesium solid plus, now this is MgCl. So over here, we're going to have 1/2 chlorine gas goes to MgCl solid. Okay? Now, in this hypothetical compound, magnesium must have a 1+ charge because chloride has a 1- charge, right? So, the way I suggest that you set up the cycle is to look at the formula of this, and this will tell you what ions you need up here. Magnesium plus in the gas phase plus chloride ion in the gas phase. Okay, now we're trying to find this. This is our quantity that we want to solve for because this is the formation reaction for this hypothetical compound, MgCl. And so Hess's law says if you could set up the cycle in a series of steps that start at the same place and end at the same place, the sum of the delta H's for those steps will be the same as this. So we need to go magnesium solid to magnesium gas. And up here we have magnesium solid to magnesium gas plus 148 kilojoules. Then magnesium gas to magnesium single ion, single positive ion in the gas phase. That's IE1 for magnesium. That is plus 738. Okay? Now, with the dichlorine, we've got to break it into chlorine atoms, and that'll take 1/2 of the bond energy. The bond energy is 244 here. So that makes 122 kilojoules for that. And then we've got the chlorine going to chloride ion when it accepts the electron from the magnesium over here. And this is negative 349. And then we have the lattice energy for magnesium chloride is something close to the lattice energy for sodium chloride, similar, negative 784. So what we have to do here is to say the delta H of formation of magnesium monochloride, this weird stuff, is equal to the sum of all the steps, the enthalpies of the steps here. So this is plus 148, plus 738, plus 122, minus 349, minus 784. Let's see if I calculated a number. I got negative 130 kilojoules, approximately. So the cycle will let you solve for any part of it, assuming that you have all the other parts. That's the power of the cycle.